So timber is what they call anisotropic. Anisotropic, the properties are different depending on direction. How do you fix that? If you look at plywood or chipboard, they physically, plywood I've just drawn up here, they cut slices of the tree just like on a gigantic pencil sharpener called veneers. Just imagine steaming the tree, heat it up to 80 degrees so it's soft as. Stick the whole tree in a lathe, put a blade that's 5 metres long against it and just peel it off, just like a pencil shaving, 3mm thick. And then they put those plies, the veneers, at 90 degrees to each other. So that's the strong direction on that one. Strong that way, strong, strong, strong. There are always an odd number of plies because here the grain direction's going that way. Underneath, for appearance, the grain direction goes the same way. So I get 3 ply, 5 ply, 7 ply, 9 ply, simply just for looks. That veneer is held together with a glue called melamine formaldehyde, a thermosetting polymer. Thermosets, there's the polymer chains. The aldehydes cross-link it. It's worth pointing out as well, so cross-linked polymers have got, a thermosetting polymer is cross-linked. It's worth pointing out as well that formaldehyde has been linked with cancer if it's free, which is why now they have low formaldehyde boards and they've developed other glues that don't release formaldehyde. It's only a problem when it's not chemically bound, when you've added too much formaldehyde and not enough melamine. So that's plywood. Glulam beams, building beams. If you look at timber structure, for engineering purposes, we spoke about stress raisers. If I have got a knot in the timber, there's a big round circle going all the way through the tree, that is a stress raiser. You do not want to be trusting a timber beam to hold up your roof if it has a stress raiser in it. So glulam beams, the engineered beams, they physically cut out the knots and glue them back together again. Of course, the joints are all misaligned. So that is then glued together with melamine formaldehyde glue again in a solid beam that is now defect-free, save for the glue lines. Because it is free of gross defects such as knots or splits in the timber, it's stronger than a traditional wooden beam the same dimensions with knots all through it. So glulam beams are an engineered composite beam. The other one worth noting, the RTA are currently reinforcing some of their old timber bridges by physically getting a shed of carbon fibre and epoxy gluing it underneath the beam. If you think about it, there's a beam with a car on it, pushes it down in tension, there's a car wheel, there's the car that's trying to put the beam like that. If the beam is old and weak, it's bending too much. How do you stop it? You get a layer of carbon fibre underneath that is stiff and strong in tension, and you reinforce underneath the bridge to keep the beam intact. That's essentially timber and composites as far as engineering. Just a quick brain dump.